In this video, I will be explaining you a problem that you can see in the second unit of Calculus of Variation and Integral Equations paper. Okay, so this is a very important question. So here, let me read the question. Derive the Euler equation. That is, they are asking us to derive the Euler equation, right? Yes. In finding the maximum value of this, that is, using this you are going to derive the Euler equation. Also they are given you a constraint. It means a condition is given, that is this. Okay. Using these two we are going to derive Euler equation. So let's see how. So first write the first line that you are going to write in this, the solution of this question is just copy it down from the question and put equal to 0 with this. Okay, that is the first line you are going to write. So let me show you. Copy down from the question and put equal to 0 to this. And then what you are doing is, this can be written like this. What they have done, just bring this delta inside this integral. Okay, now what you are doing is, here you are going to differentiate this. Okay, when you differentiate this, you will get this. Okay, I will tell you how to write this. Okay, without any difficulties in writing this step. Okay, so I will tell you how. First write this f and then write everything that is inside this bracket except this x. Write like this, write in order. And then what you are writing is, from this you can write without any confusions, without any difficulties, you can write by your own. So I will tell you how. First write dou f by dou u. Dou f by dou u into delta u, dou f by dou v into delta v, dou f by dou ux into delta ux, dou f by dou vx into delta vx. You can check it out whether I am right or not. Okay, so just write this integration as it is in the previous step, and then you can differentiate this so that you will get this, and then put this dx equal to 0. And then what you are doing is, in the next line, you are multiplying this integration and dx to all the terms so that you will get this. Right, and in the next line what you are doing is, write these two terms as it is in the previous step, and in this step a small difference you are making. In these two terms you are making a small difference, that is, in the place of ux, in the next step you are putting dou u by dou x, and in the place of vx, in the next step you are putting dou v by dou x. That is the only difference you are making. And then what you are doing is, write these two terms as it is, and here also you are making a small difference, that is, you are going to pair this two. Delta, is that delta? Delta and u. Okay, and you are separating this dou by dou x from this u. That is what you are doing. Just look at this step. Write everything as it is, and here just you are splitting dou by dou x from this u, and you are pairing delta and u. So look at this, you will get this. The same difference you are making here also. Okay, now what you are doing is, in the next line, write these two terms as it is in the previous step. Here what you are doing is, you are going to integrate this in a way that we have an integration method, udv method, right? Like that you are integrating this. You are consider this as u, this as dv. Okay, using that formula you are going to integrate this. The formula I have wrote here. Okay, you can see that for reference. So uv, okay, dv is this. So from this you have to find the value of v, so that you will get this uv, and write the limit minus integral. This is v, right? You have found it from dv, v, and this is a du. You have found it from this u. Okay, the same thing you are doing for this term also. You are considering this as u and this as dv. Okay, the same process, the same formula you are using and integrating these two terms. Okay, and from this what you are doing is you are eliminating these two terms from this step. So after eliminating, you will get this line. This line what they what in this line what they are doing, consider these two terms. In these two terms you can see this integration and delta u dx. This integration delta u dx are common, right, in these two terms. So from these two terms you are taking this integration and delta u dx common, so that you will get this line. Okay, also look at these two terms. In these two terms you can see this integration and delta v dx common. Okay, so that you can take that common and write the remaining like this. Okay, so that you will get this step. From this step you can have this integration. Here you have two terms. In these two terms you can see this integration and dx are common in these two terms. So take that common and you will get this step. Mark it as equation number 1. Okay, is that clear? Now in the next line what you are doing is, you have another constraint is also given, right? And a constraint is given, so use that to proceed further. So given, write it and then multiplying this with the delta, so that you will get this. Now you are differentiating this. You are differentiating this in the same way that you have did for this step. Okay, so just write pi here and u and b near to this. Okay, for to make you feel easy, you can follow this step. Okay, to make this to make you to feel easy to write this step, you can write like this in a side of your paper, so that from this you will get dou pi by dou u into delta u and dou pi by dou v into delta v equal to 0. You will get this step. And here in the next step what you are doing is, in the place of dou pi by dou u, you put pi u. In the place of dou pi by dou v, you can put pi v, so that you will get this. Now you are integrating this with respect to x over this limit. Okay, yeah, in the integration you are going to put this limit. Okay, you are differentiating with respect to x, so that you will get this step. And now what you are doing is, you are multiplying with a Lagrange's multiplier lambda. Okay, so that this step becomes like this. Now mark it as equation number 2. Adding 1 and 2, you will get this line. From this, here you can see this is the coefficient of delta u and this is the coefficient of delta v. So just write it down. And these are the required Euler equation, and these two equations can be rewritten like this, right? And this is our required Euler equation. This is what the question they are asking us to derive, and finally we have derived it. Okay, thank you.